Welcome all. Welcome to the KTHM College Nasik. My name is Parkhe. I am working as an assistant professor in the Department of Physics. And welcome to the third year B.Sc class. And we have the course Astronomy and Astrophysics. Astronomy is the branch of space science which study the entire universe beyond the Earth's atmosphere, and also to measure the motion, position, luminosities of the stars and other characteristics of the matter in the entire universe. Astrophysics is the branch of astronomy which also study the entire universe by applying the laws of physics and to describe the theory associated with it. The main aim of the astrophysics is to study how the universe works, how it begins, how it evolved, and to study the life on the other planets. So this is the main difference between astronomy and astrophysics. Today we are going to discuss on the origin of the universe. So before discussion of the origin of the universe, let me tell you one story. So in the beginning, the man from the earth started look at the sky. He saw two planets in one side and one planet in the other side. Then after that, he saw one asteroid belt having dust, particles, gaseous clouds, rocks, metals, and etc. Then after that, he saw three planets and one Kuiper belt having also dust, particles, gaseous clouds, and ice rocks. Then after that, he saw a big gaseous cloud. And then he found one star. Then he was keep observing. Then he found so many stars. Then the clusters of the stars. Then the supercluster. Then finally he saw a galaxy, a whole galaxy. Then he was keep studying and moving on. He found so many galaxies. Then the clusters of the galaxies, supercluster. And finally, billions of stars. Then what was that? That was our universe. Then he moved his radio telescope and he observed one very amazing thing, that everything in the universe is running apart and away from each other. Then he concluded that if everything is running apart and away from each other, then that means the universe is expanding. And if the universe is expanding, so we should have to go back to the point where it started to expand. Then he went on to the time scale and started compressing everything back to the time 0. And then he assumed that the universe was nothing anything. It was just a single point having infinite density and infinite temperature. Then with the help of laws of physics, he predicted and he described the theory. He described the theories associated with it, that how the universe began and how it evolves. So this is the simple story. The story was so amazing and interesting, but unfortunately, we should have to study this story. We should have to make notes and diagrams. So let's discuss the origin of the universe. So to understand the origin of the universe, we have to go through some theories associated with it. The people describe their assumptions and their predictions with the help of laws of physics and science. So the most preferable theory nowadays is the Big Bang theory. Let me write it one by one. The first theory is the Big Bang theory, which is most acceptable theory nowadays, because all the data we collected by experimentally and theoretically about the space science, which is accurately and completely fit in this model. The second one is But this is one of the many possibilities, because in the universe we are in very small scale. So we should not ignore other possibilities also. So the next one is steady state theory. Now the very interesting and very humbling theory. Eternal inflation. And the fourth one is oscillating universe. I hope you all familiar about the Big Bang theory, which is most acceptable and more preferable theory nowadays. And in steady state theory, nowadays this theory is discredited because it failed some assumptions according to the laws of physics and theory. And there are other also, but we will go through the Big Bang theory first. So to understand the Big Bang theory, in the beginning of our class, our space traveler observed that in the universe, everything is running away from each other. Then he concluded that the universe is expanding. And then he went on to the time scale and started compressing everything back. And he assumed that the universe was just a single point having infinite density and infinite temperature. So that point is known as singularity. Singularity. And when the Big Bang happened, here. Let me draw one figure which represents the origin of the universe till the date. And here a time scale. All right. So singularity is just a single point having infinite density and temperature. And since all the forces, if the universe is just a single point, so since all the forces, including gravitational force, nuclear force, electromagnetic force, all the forces were unified at this time 0 second. Okay? So in the beginning, all the forces were unified and the quantum fluctuations occurs. Quantum fluctuations occurs. Quantum means a very small things which we can discuss anything in subatomic scale or microscopic level scale. Quantum fluctuations occurs, and quantum fluctuation means the small change in energy in these quantum things, and hence the inflations at time 10 raised to minus 32 second. The inflations, the process inflation were going on up to 10 raised to minus 32 second. Then at time a very small time it is. 10 raised to minus 32 means very small time. Very quickly this process happened after the Big Bang. At 10 raised to minus 6 second, protons form. Protons form. That means the charged particles started to form at 10 raised to minus 6 second. At 0.01 second, nuclear fusion occurs. Nuclear fusion is a process in which two nuclei fuse together and to form a new nuclei, and during that process some amount of energy is released in the form of nuclear radiations. So therefore nuclear fusions, this process occurs at 0.01 second since from the beginning, and this process we are going on up to 3 minutes. 3 minutes. Nuclear fusion end. Now after that you can see that the time scale will be rapidly changed. After 3.8 millions years, after 3.8 millions years, the process, very important process, recombination takes place. In that process, one proton and one electron recombine and they form a neutral hydrogen atom. And during that process, some amount of energy is released in the form of radiations. That means the first radiations coming out. The first radiations was coming out, and that radiations are, let me write it here, cosmic microwave background radiations. These are the first radiations which came out during this recombination process. That means the first light came out and the universe became transparent at 3.8 million years since from the Big Bang. So the cosmic microwave background radiations. These are the first radiations emitted after the Big Bang, CMBR. Then after $300 million years, after 300 million years, the stars and the galaxies form. And now at 3.8 billion years, we have the present universe. We have the present universe at 3.8 billion years. So we can conclude that the age of the universe till the date is 3.8 billion years since from the Big Bang happened. So this is the theory, and this all content in this diagram it's experimentally and theoretically proved that according to the general theory of relativity. So this is the Big Bang theory, and the universe is expanding continuously with the time. Nowadays this is the most acceptable theory. Now the second one is the steady state theory. According to this theory says that yes, they agree that universe is expanding, but they do not agree that the Big Bang happened. According to this theory, the matter is continuously created in the space, and the space itself is expanding according to this theory. But some assumptions of this theory failed some assumptions according to the laws of physics. It doesn't mean that when the Big Bang happened, there was already space around it and filled by the insane universe. But the fact is that there was no space around it. The space itself was created along with this inflation. There was no space around it. The space itself was created along with this inflation, according to the Big Bang theory. So the next is the eternal inflation. Very interesting, eternal inflation. According to the eternal inflation, yes, after the Big Bang, and along this inflation of the universe, there could have been created a universe. When the Big Bang happened, there could have been created a universe which is expanding along this direction where we are living right now. There could have been created another universe which is expanding along this direction. There could have been created another universe which is expanding along this direction. There could have been created another universe in which some other intelligence somewhere might be sitting and thinking in some other languages, and you call them as aliens. So there could have been created infinite number of universes, and all these universes which is expanding in all directions. So this is our universe. This is the universe for us, but there could be multiverse. So this is the eternal inflation. Very humbling theory it is. Now we are moving in big territory. In oscillating universe, according to this theory, the universe is expanding continuously due to the expansion energy. And when this expansion energy, due to the expansion energy, the universe is continuously expanding. When the expansion energy finished, everything will come back to the point where it started to expand. That means the universe will become collapse. And again the Big Bang will happen. And again the inflation, due to the inflation, the expansion is occurs. And due to the expansion energy, the universe is expanding continuously with the time. After certain time, the expansion energy finished and everything will come back again. So this oscillating process is continuously going on. But unfortunately, I don't know that we'll be there after this collapse, this universe. Anyways, so this is the oscillating universe. So these are the theories which describe the origin of the universe. Alright, so the next point is, you can draw this diagram and the content associated with it. So this is the general introduction of the origin of the universe, and this is the schematic of the universe after the Big Bang till the date. These are the theories which describe this origin of the universe. Now the next topic is Nebular Theory. Nebula means a gas cloud. Nebula. So according to this theory, Nebular Theory explains the formation of stars and planets. It explains formation of stars and planets. According to this theory, there is a big gaseous cloud or a giant molecular gaseous cloud, and which is spread over the interstellar area. Interstellar area means it is the empty space in between the stars. That is the interstellar area. So this gigantic molecular gas cloud is spread over the interstellar area, and since it is cold, then after that, let me draw a figure. So this is the cold cloud. Molecular gas cloud. These are the molecules, gas molecules. And it is spread over the interstellar area. And the step 2, since it is cold, all the molecules, due to self-gravity, this gas cloud contract. All the molecules pull together due to self-gravity. Self-gravity is a very important force which is exerted on the bodies by the body in astronomy and astrophysics, because we can see this solar system, we can see our solar system due to the self-gravity. Otherwise, if we see the planet today, in the next day, we could not able to see that planet, where it has gone. Might be in the other universe also. So the self-gravity, so due to self-gravity, all the molecules are try to pull together, because this force, self-gravity, is allowed to hold all them together. So due to self-gravity, they contract, this gas cloud, molecular gas cloud, contract, and hence the internal pressure due to these gas molecules, which is acted outward direction, which is very less, very much less than the gravitational force, self-gravitational force. So the self-gravitational force is acted inward direction, and the gas molecular cloud contract, and it will become more denser, and after that it acquire, these gas molecules acquire angular momentum at its center. It acquire angular momentum at its center, and the conservation of this angular momentum pulls the cloud into a disk. You can see here. So the conservation of angular momentum pulls the cloud into a disk in anti-clockwise direction. In anti-clockwise direction. And the entire matter in this molecular gigantic molecular cloud, the entire molecules, or we can say that the entire matter rotates and they collapses on each other, and the protoplanet is formed at the center. The protoplanet is formed at the center. And also, the gaseous protoplanetary system is produced around the protostar. This is the protostar. And this is gaseous planetary system, which is produced around the protostar. And this gaseous protoplanetary disk form here. These form the planetary systems. So due to this angular momentum, our entire matter which is rotating around this protostar, it forms a planet. So this is the solar system, description of the solar system. Let me summarize it. There is a gas molecular gas cloud, a big molecular gas cloud which is spread over the interstellar area, and due to the self-gravity all the molecules try to pull each other, and due to self-gravity the gas molecular cloud contract, and all the molecules acquire angular momentum. And the conservation of angular momentum, due to conservation of angular momentum, this molecular cloud form a disk shape and rotating around anti-clockwise direction. And due to the matter rotates, collapses, a protostar is formed at the center of the disk, and the gaseous planetary system is formed around the protostar. And this gaseous protoplanetary disk evolves the planets. So this is our solar system. So this model, which is also most acceptable and most preferable model, nebular theory, which is described by Kant and the Laplace. So according to this theory, we can observe our solar system, which is completely our data of our solar system, which is completely fit in this model. So this is the Big Bang theory for you, but I'm sure today's you have the big bomb for the others, and the most horrible sentence of today's lecture is that there could be one possibility that the universe may collapse after the finish expansion energy. So before you collapse your mind, we'll stop here and we'll see you in the next class. Thank you very much.